Hello everyone. So today we will see generation of number sequences. And in this topic we will see the subtopics linear sequences, nonlinear sequences, and what is the term to term rule for the generation of number sequences. So first we will see what is a sequence. Here you can see one example 3 comma 5 comma 7 comma 9, and you can see three dots here, so which means that this sequence is a infinite sequence. If the three dots are not there, then it is a finite sequence. So the each number, that is 3, 5, each number in the sequence can be called as term, element or member. So the 3, 5, 7, 9, then the next element can be 11. The next element can be 13. So like that it is going on. Okay, so that is an infinite sequence because it can go up to infinity. Okay, but if it is 1 5 9 13, there is no etc or the dots are at the end of the last element, then this is a finite sequence. It is having only 4 elements 1 5 9 13, but here it is having infinite elements in the sequence 3 5 7 9 11 13, and again it can be 15 17 like that. Okay, so that is sequence and infinite sequence. This is infinite sequence and this is finite sequence, and you have to understand what is term, element, member. Okay, so we will call each member or each number of the sequence are as term, element or member. Okay, so in short, what is a sequence? A list of numbers. It is not list of things, list of numbers in our case, which are arranged in some order. Okay, so that is a sequence. Okay, so we have seen what is a sequence and what is infinite sequence, what is finite sequence, what is term, element, member. All these things we have seen. So now we will move to the next one, very important, that is what are linear sequences and what are non-linear sequences. We will see one with one example 8 16 24 32 40. So this is a sequence, whether it is a infinite sequence or a finite sequence. This one, the first one, it is a infinite sequence because you can see the three dots here. Okay, so not only this 5 elements, some more elements are there. Okay, then 8 is the first element. The next element is 16. The next element is 24. The next element is 32. Next element is 40. Okay, so you just look on this 8 and 16. Along with 8, when I add 8, I will get 16. Along with 16, when I add 8, I will get 24. Along with this 24, when I add, I will get 32. Again, along with this 32, when I add 8, I will get 40. Which means that when I am taking two terms, between that two terms, there is a constant change between every two terms in the given sequence. So it is a linear sequence. Linear sequence change the same between terms. Okay, another simple example, this one 31 32 33 34. I am just writing the sequence here 31 32 33 34. Very simple. Along with 31, When I add 1, I will get 32. Here again plus 1, I will get 33. Plus 1, I will get 34. Okay. So here also you can see that, okay, between every two elements, the change is constant. And that change is 1. Okay. So now we will see non-linear sequence. That is, I have just taken two examples. From those two examples, I hope you understood what is linear sequence. Anyway, the other examples also we will see in the next slide. So now we will see what is a non-linear sequence. Again, we can get the help of one example. And I am just writing that here. 2, 5, 9, 14, 20. Okay. So along with 2, I can add 3. Then only I will get 5. Along with 5, if I add 3, I will get 8 only. But here it is 9. Which means the difference is 4. Here the difference is 5. Here the difference is 6. Which means that when I am taking any two terms, there is a change or there is a difference between that two terms. But that change is not a constant for all the terms in that sequence. Okay. If I take these two elements, that changes 4. But if I take these two elements, that changes 6. Which means that that change is not constant. Okay, then it is a non-linear sequence. So non-linear sequence do not change the same, a constant amount between the terms. I will take one more example here. 2, 4, 6, 8, 11. I will just write here 2, 4, 6, 8, 11. Okay, so here along with 2, when I add 2, I will get 4. Okay, along with 4, when I add 2, I will get 6. Along with 6, when I add 2, I will get 8. Along with 8, when I add 3, I will get 11. Okay, or when I add 2 along with this 8, I will get only 10. Okay, so which means that here it is 2, here it is 2, here it is 2, but here it is 3. Which means between every two elements in the given sequence, 2, 4, 6, 8, 11, there is no constant change. The change is not constant. Okay. In one place it is 3. Okay. Because of that reason, it is a non-linear sequence. So very simple. Linear sequence means the change will be constant. The same change between all the terms of that sequence. But here, non-linear sequence, the change is not constant. Okay. So now we will move to the next subtopic, term to term rule. So this is the previous case, the previous examples. For each of this example, we will see what is the term to term rule. So with that, you will get some more idea about what is the linear sequence. Okay. So till now, if you have any doubt regarding the linear sequence, that doubt will be clarified. So we will see what is a term to term rule. Again, we will take the first example. The example already we have seen. Along with 8, I can add 8, then 16. Along with 16, add 8, 24. So simple, very simple. What is the term to term rule here for the first example? Add 8. That is the rule. Understand? That is the rule. Add 8. Okay. So this is the first term. Along with the first term, add 8. Then second term. Along with the second term, add 8. Like that. The second example. 7, 15, 23, 31, 39. What will be the term to term rule? Okay, so that sequence we can just write here. 7, 15, 23, 31, 39. Okay, so Along with 7, I can add 8. Here 15 plus 8 is 23. You can check. 23 plus 8, 31. 31 plus 8, 39. So again, what is the term to term rule here? For the second example, add 8. So now we will see this one. This one already we have done, no? 31, 32, 33, 34. So this is the fourth example. What is the term to term rule? Already we have seen that. Add 1. Add 1. Okay. So now we will see another simple example. This one you can tell very easily. A plus 3, A plus 6. That is, A means some number, A. Along with that A, I am adding 3. Along with that number, A plus 3, again I am adding a 3. Then it will be A plus 6. Okay. So, what is the term to term rule here? For the sixth case, add 3. Okay. So, now we will see another two examples. Here the third one. I am just writing the elements here. Minus 3, minus 10, minus 17, minus 24. Okay. So I hope you have studied about the negative numbers. So this is minus 3 and this is minus 10. Okay. So along with minus 3, when I am operating something, I will get minus 10. So minus 3, if it is 3, along with 3, when I am operating something, I will get 10. What I have to operate? I have to add 7, isn't it? 7 plus 3 equal to 10. So like that, here it is minus 3 and here it is minus 10. So minus 3 minus 7. Minus 3 minus 7. That will be minus 10. So minus 10 minus 7. What will be the answer? 10 plus 7, 17. Then put a negative sign because here both the operands are minus or negative numbers. And along with minus 17, minus 7. What is 17 plus 7? 24. So minus 24. Okay, so here you can see that the minus 7, here minus 7, minus 3, minus 7, minus 10. Minus 10 minus 7 minus 17, minus 17 minus 7, it is minus 14. Okay, so here minus 7, so that will be the term to term rule, minus 7. Okay, then here you can see that fifth example. I will just write the elements here. 7, 2.5, minus 2, minus 6.5. Okay, so this is example with the fraction. So 7, 2.5. From 7, how it will be 2.5? I can subtract 7 and 2.5 because we know that it is a reduction in that number. So I can subtract. Then here it will be 10. 10 minus 5, 5. So here it is 6, 4.5. Which means here a subtraction has done 4.5. That is the difference between these two. Then from this 2.5, I am just checking. I am subtracting this 4.5. Okay. That is 7 minus 2.5. That is 4.5. Okay. Then what is the difference between 2.5 minus 4.5? If again a 4.5 is reducing from 2.5, what I will get? I will get here 0. Since I am subtracting from a smaller number, it can be treated as minus 2. So I am getting minus 2 here. Okay. So again the difference is minus 2. And again here the difference is 4.5. Then I am getting minus 6.5, which means that here I have to subtract 4.5. Okay, so that is the term to term rule. Or in the previous slide we have seen, when I am taking any two terms, the difference or that change should be constant, isn't it? And that constant change is called as term to term rule. Okay, what I have done on the first element in order to get the second element, what I have done on the second element in order to get the third element, like that. So that is the rule, term to term rule. Okay, so now we will see some other example with the non-linear sequences. So the first one I am just writing here: 2, 5, 9, 14, 20. Okay, then here along with 2 I have to add 3, right? Then along with 5 I have to add 4. Along with 9 I have to add 5. Along with 14 I have to add 6. So here you can see that change is not constant. So here I can write the term to term rule as add 3, 4, 5, 6, etc. Okay, which means that what will be the next element in the sequence? It will be 27, because along with 20 I have to add 7 in order to get the next element. Again, along with this 27, what I have to add in order to get the next element? 8. So the next element will be 35. Okay, like that. So that will be the rule here. 3, 4, 5, 6, 7, 8, 9, 10, like that I have to add. Okay, so that is the first one. So here you can see that clearly, you can understand that these are the changes, but these changes are not constant. That is why it is a non-linear sequence. Okay, did you get that? What is term to term rule? And if that term to term rule is following a constant change, then it is linear sequence. Otherwise it is a non-linear sequence. Then the next one, 7 comma minus 7 comma 7 comma minus 7 comma 7. Here I will just write that 7 minus 7, 7 minus 7, 7. It is very simple. Multiply minus 1. 7 into minus 1. What is the answer? Minus 7. Along with this minus 7, I am multiplying minus 1. What is the answer? Minus into minus, it will be plus. So plus 7. And again I am multiplying it with minus 1. Then it will be minus 7. Again I am multiplying it with minus 1. That it is 7. Okay, so here what is the term to term rule? Multiply. So multiply minus 1. Multiply minus 1. Okay. But here when you see, you can see that it is 7 minus 7, 7 minus 7, 7. Okay, in that order it is going. Okay. So now we will see the third element. 2, 4, 6, 8, 11. So tell me, what is the difference here? 2, or along with 2 I have to add 2. Here plus 2 I will get 6. Here plus 2 I will get 8. Here plus 3 I will get 11. So 2, 2, 2, 3. Okay. So this is not a non-linear sequence, and also there is no term to term rule here. Okay. Even though the sequences are non-linear sequence, they may have some term to term rule, because in the first case we can see that it is the change is not constant, but there is a pattern for the elements. Okay, that is first 2 comes, then 5 comes, then 9 comes, then 14 comes. That is it is added with 3, 4, 5, like that. There is some pattern. Okay, so there is a rule, but it is not a non-linear sequence. But for this case, the third case, it is not non-linear sequence and it is not having any rule also. Because the first 4 elements follows plus 2 plus 2 plus 2. Then the last element, it is plus 3. So there is no specific rule for that. Then the fourth one, I will just write that numbers 100, 80, 70, 65. So here, how I will get 80 from 100? Minus 20. Here minus 10. Here minus 5. So like that, subtract 20, 20, 10, 5 like that. Okay, then what will be the next number? Here 20 becomes 5. It becomes 5. 10 becomes 5. Okay, that is a 10 difference. Then 5 difference. Then it should be 0. That is, I will get the same element. Then maybe it is minus 5. Like that it will go also. It will go on. Okay. So now we will see the fifth one. 1, 4, 9, 16. So this is 1 itself. This is 2 square. This is 3 square. And again I hope you have studied the square of a number. Okay. 3 square, 4 square, like that. So here in which order it is going? The square of the number. The square of the number. So square 1, 2, 3, 4, 5 like that. That is the rule. So there is a pattern there. Okay. But when that sequence appear, there is no a common or that change difference between the elements are not having a constant change. That is why it is non-linear, but there is a rule. So now I hope you got what is a term to term rule. The term to term rule means what is the change has occurred for the two terms, okay, or for all that terms of the sequence. Okay, so now we will see the examples or the questions which are given in your textbook. Okay, the first one, are these sequences are linear or non-linear? The first one, A. I am just writing the sequence like this: 6, 4, 2, 0, minus 2. Very simple. 6, 4. How I will get 4 from 6? Minus 2, subtraction. From 4 to 2, how I will get? Minus 2 again. From 2 to 0, 2 minus 2 is 0. 0 minus 2, minus 2. So here you can see what are the changes? Minus 2, minus 2, minus 2. Constant change. Okay. So A is a linear sequence. A is a linear sequence. Okay. So now we will see B. 8, 5, 1, minus 4, minus 10. Okay. So tell me the difference. Minus 3. Right. From 5, minus 4. And here from 1, minus 5. Okay. That is how I can perform 1. From 1, I have to subtract. Subtract minus 5 from 1. Okay. Then 5 minus 1, 4. And the largest number is having a negative sign. So answer will be minus 4. So here the difference is minus 5. And here minus 4 to minus 10. From minus 4, along with minus 4, I have to perform minus 6. That is minus 4 minus 6. Then it will be minus 10. So you can see that This is the order. Subtract 3, 4, 5, 6. Okay, subtract 3, 4, 5, 6. So you can see that the changes are there, but that changes are not constant. So this is a non-linear sequence. Okay, I hope it is clear. So now we will go to the second question. The first term of a sequence is 4. Term to term rule is given. Multiply by 2. Very simple question. Write the first 3 terms of the sequence. 4. That is the first term. So you can write first term equal to 4. Okay. Then term to term rule. Multiply by 2. Okay. So second term. What will be the second term? Second term will be 4 into 2. That is 8. The third term. What will be the third term? 8 into 2. 16. So the sequence will be 4, 8, 16. These are the first 3 terms. Did you get? Okay, very simple. We will do one more question. First term. What is the first term? 3. And term to term rule is square, then subtract 5. Okay. So how I will get the second term? The first term I have to square. 3 square, then subtract 5. So 3 square is 9. 9 minus 5, it is 4. How I will get the third term? Third term equal to second term. I have to square and subtract 5. So 16 minus 5. It is 16 minus 5. 16 minus 5, it is 11. So 11. So what are the first 3 terms? First 3 terms equal to 3, then 4, then 11. Okay. So this is the last question. So I hope you understood what are the linear sequences, what are the non-linear sequences, and what is term to term rule. Okay. So linear sequences means a constant change between all the terms in the sequence. Non-linear sequence means changes will be there between the terms, but that changes are not constant. Term to term rule means what is the change occurred between the terms. That is term to term rule. Okay. So then we have done some problems also. Okay. So with this we can wind up the generation of the number sequence. Thank you.